Hello, welcome to ANS Solver. This is the third question of the paper. So here I need to find the equation of the normal to the curve. Okay, so this is the equation which they have given me. Okay, and this is the point. So now if you see, I'll just write the equation again, for your reference. This is the equation which is given to me, correct? So now I know I need to use something called as implicit differentiation here. Okay, why? Because it's the easiest way to identify this. They have used two different letters here, correct? Like that's the most layman way of explaining it. That's why you need to use implicit differentiation. So now let's start by differentiating everything. The differentiation of x square into ln y. If you see here, I use the product rule here because you know x square is multiplied by ln y. So in the product rule, I take my u as x square, okay, and I take my v basically as ln y. So now I take my u dash, sorry, this is u dash. I take my u dash basically as x square differentiation, which is 2x. And I take my v dash basically as ln y differentiation, which is 1 over y. But an important rule which you need to remember in implicit differentiation is that whenever you differentiate something consisting y, a dy by dx is multiplied. Okay, now what I need to do is, I know my product rule formula is uv dash plus vu dash. So I can simply substitute to get x square over y dy by dx plus vu dash, where I get 2x ln y. Got it? Now I need to differentiate 2x here, which is simply 2, and the differentiation of 5y is 5. But I told you, whenever we differentiate y, I multiply dy by dx. Now I have a constant here. A differentiation of a constant is always 0. So now what I basically need to do is, I have basically everything with me. I just need to write this as x square over y dy by dx plus 2x ln y, okay, plus 2 plus 5 dy by dx is equal to 0. So now what I can do is, I can write this as x square over y dy by dx plus 5 dy by dx is equal to minus 2x ln y minus 2. Now what I can do is, simply I can take dy by dx common to get this as x square over y plus 5, which is equal to minus 2x ln y minus 2. Now what I can do is, I can simply write this as dy by dx equals to minus 2x ln y minus 2 over x square by y plus 5. Okay, now what I need to do is, I know my points are 3 and 1, which tells me that my x is 3 and my y is 1. So what I can simply do is, I can write this as dy by dx equals to minus 2 into 3 ln 1 minus 2 over x square, which is 3 square by 1 plus 5. So now I can basically write this as dy by dx equals to ln 1 is basically 0. So I get minus 2 into 0 is 0, so I only get minus 2 over 3 square I know is 9. 9 plus 5 is basically 14. So 2 ones are 2 and 2 sevens are 14. So my dy by dx is basically equal to minus 1 by 7. Okay, now you tell me, I need the equation of a normal, correct? Equation of a normal has an equation of y equals to mx plus c, where m is the gradient. I already have my gradient, which is my dy by dx equals to minus 1 over 7. So now you tell me, is my m here minus 1 over 7 or no? You can pause the video, think about the question and then say. Okay? See, you need to understand a concept. Whenever they use, this is really important, so I'll make a line here. Whenever they use tangent, I can use the same dy by dx. But whenever they use normal, okay, the dy by dx or the gradient needs to be the reciprocal and negated, or the opposite sign should be implemented. So now if I'm telling you that here my dy by dx is minus 1 over 7 and I need the equation of the normal, that means I need to reciprocate first, which will give me negative 7, and now the opposite sign. So my m will basically become positive 7. Got it? So that means my m is equal to 7 here. Got it? Now I have my coordinates, which is 3, 1. Okay? So I need to find c here to get the equation. So my y is 1 equals to 7 into 3 plus c. So now I can write this as 1 equals to 7 into 3 is 21 plus c. So c equals to 1 minus 21, where c equals to minus 20. So now I can write my equation basically as y equals to m, where m is 7, x minus 20, which is c. So this is basically the equation of the normal. So this property is really important to understand, normal and tangent. We have done this in AS also, but yeah, you need to remember it.